Greetings, children. It's time for us to learn how to balance chemical reactions. Ms. Sangarasa, are you ready?
Sure am.
Good. Well, before we begin, could you please tell me why do we balance chemical reactions?
We balance chemical reactions because mass is conserved. Remember when you were eating the bread?
Yeah.
So you have to have the same number of each element on both sides for mass to be conserved.
Same number of each element on both sides. So if I look at a reaction like I'm going to look at here, let's draw it out. H2 plus O2 yields H2O. This is when we combine hydrogen and oxygen gas to make water.
Okay.
So let's first talk about a couple of things. We've got these little numbers right here. See these little 2's? You know what those are called?
Subscripts.
Subscripts. Exactly right.
What
The
is
numbers that I'm going to put right here are going to be called
coefficients.
coefficients. Now, what is the difference between those two? Well, the subscripts tell me how many of that element or that atom there is. So H2 means there's 2 hydrogens in hydrogen gas.
Okay.
H2O means there's 2 hydrogens in water, and then there's 1 oxygen. You don't have to put a 1 in the subscript.
Okay, but what if I had 2 in the coefficient place in front of H2O?
That would mean you have 2, and I'll show you what that looks like even though we're not done yet. So if I had a 2 in front there, that means I just have 2 waters.
Right.
2 H2Os.
Okay, so we'd have 4 hydrogens and 2 oxygens.
Correct.
Okay.
So let's actually take you through this whole process here. I like to first find the arrow right here. Look at this arrow, and directly below it, I'm going to list every element that I see in this reaction.
Okay.
I've only got H's and O's. Okay, then I'm going to put dashes on either side because that is going to help me decide how many I have right now on each side.
Okay.
So how many hydrogens do you see on the left side?
I see 2.
Great. How many oxygens do you see on the left side?
2.
How many hydrogens do you see on the right side?
2.
Okay, and oxygens?
Only 1.
Only 1. So this is not balanced because we have equal numbers of hydrogens but unequal numbers of oxygens. We need to fix that.
Okay.
So how do I get 2 oxygens on the right side? Well, I'm going to change the coefficient in front of water.
Okay, let's make it a 2.
If I make it a 2, right here, what I have done is I've now changed how many hydrogens and oxygens are on the right side.
Okay.
So 2 times 2 hydrogens gives me a total of 4 now.
Okay.
But it also changed my oxygens. I have 2 times 1 oxygen gives me 2. So we're distributing that 2 just like you do in math. All right,
so we have 2 of the whole compound.
That's right.
Okay.
So what about now? Are we balanced?
Not quite.
Okay, we still have to balance those hydrogens on the left side. I need 4 hydrogens on the left side. So what coefficient could I put in front of the hydrogen?
A 2.
I could put a 2. Fantastic. So that means 2 times 2 hydrogens on the left would be
4.
4. 4 hydrogens, 2 and 2 oxygens. I think I am balanced. All right. And if there is no coefficient in front of that oxygen, we would just say that is a 1.
Perfect.
Okay, so this is the balanced equation for that. Want to do another one?
Sure.
Got time, right? So let's do sodium sulfide plus potassium iodide gives me sodium iodide. This is going to be tough to fit. Potassium sulfide. Okay, got it all in there. So directly underneath that arrow, I'm going to list all of the elements that are involved. Can you rattle them off for me?
I see sodium,
okay,
sulfur, potassium, and iodine.
Great. Dashes on either side. So, Sangarasa, tell me how many sodium, sulfurs, potassiums, and iodine you see on the left side?
I see 2 sodiums, 1 sulfur, 1 potassium, and 1 iodine.
Okay, now on the right side?
I see 1 sodium, 1 iodine, 2 potassiums, and 1 sulfur.
Great. Okay, this is not balanced because we have unequal sodiums and potassiums. So pick which one you want to start with.
Let's start with the sodium. So I would put a 2 on the product side in front of the sodium iodide.
Right here?
Yeah.
Okay, so that now gives me 2 times 1, 2 sodiums, but that also gives me 2 times 1 equals 2 iodines.
Okay.
So now our iodines and potassiums are off. So what do you want to do next? Let's
Well,
fix
it
that.
looks like if I double the potassium iodide in the reactants,
So if
I would have 2 of each.
I put 2 over here, I've now
Yeah.
got 2 potassiums, and 2 times 1 is 2 iodines. That should be good, right? Everything
Yeah.
looks balanced. So my remaining coefficients should just stay 1s.
Yep.
Just like that. Okay, guys, that's simple balancing, and practice a little bit, and there's another video for a little bit more complex ones with polyatomics and such.
Okay, great.
All right.